Well, hello there. So today we're going to take a look at a sampling distributions with proportions problem. In other words, we've talked about the overview of inferential statistics. We've talked about the fact that we're going to be dealing with proportions and means with our samples. In these introductory problems, we're going to know the actual mean and the actual proportion for whatever we're studying. Most of the time we're not, but here for this first part we will. So let's take a look at this example problem and try to put everything we've talked about together. Here we go. We know that 35% of all first-year college students go to school within 50 miles of their home. Let's assume that that's a known truth. So what we're going to do is we're going to test that truth. And we're going to say, okay, let's do a simple random sample of 1,500 students. And let's see what's the probability that the result of that, in other words, the question, do you attend a school within 50 miles of your home? And they say yes, right? That's our desired outcome. That's our success. Will be between 33 and 37%. Now, the answer should be pretty high, the probability, but let's verify it and let's see what it is. Okay, so first, let's summarize what we have here. We know that N, big N, is all first year college students. And we know that little n is 1,500. We want to find the probability that p hat is between 0.33 and 0.37. Okay? So before we can do that, let's do a little work. Okay, and let's test our conditions. So we know that the mean of all the p hats, in other words, if I were to conduct this survey over and over again, I should end up with 0.35. We know that the standard deviation of all those p hats should be 0.35 times 1 minus 0.35 divided by 1,500. So those are two formulas that we know that we're going to use in our calculations. This comes out to be approximately 0.123. Okay, so we're laying the groundwork here. Now let's test our conditions. First, let's think about the sample size. Is 1,500 less than 10% of all first-year college students? That is the N less than or equal to 1/10 of big N case. So in our case, is 1,500 less than or equal to 1/10 of all first years? And the answer is yes. Cha-ching. How about our proportion conditions? NP greater than or equal to 10 and N1 minus P greater than or equal to 10. These are what we call our successes and failures. In other words, is it even worth doing this project? N, 1,500 times 0.35. Yes, that is greater than or equal to 10. How about 1,500 times 0.65? Yes, that's also greater than or equal to 10. Check, check. So what do we conclude? We conclude, therefore, that our samples are normally distributed. Now, why is that important? Funny you should ask. That's important because now we can throw them onto our normal curve and work this out the way we've always done it. I think I can squeeze it right in here. So here we go. The first thing we'll do is we want to get between 0.33 and 0.37, right? So let's find our z's. So our z is going to be 0.33 for the first one minus 0.35 divided by 0.0123. That'll be Z1. Z2, 0.37 minus 0.35 times 0.0123. Now, I know what you're thinking. You're thinking, gosh, do I really have to do that? Well, if you're using the calculator or the computer, no, you don't. But I will tell you that it's good to present the z-scores, the z-values. People like to see that. So I'm just going to do this on my calculator here right now. So I'm going to do 0.33 minus 0.35. I'm going to divide that by 0.0123. And that's negative 1.626. And you can confirm these yourself. 0.37 minus 0.35 divided by 0.0123, 1.626. Okay, now we'll draw in shade. So here's my 0 line. That corresponds with 0.35. 1, 2, 3. 1, 2, 3. Here's 1.626. That's going to correspond with 0.37. And negative 1.626 corresponds with 0.33. Okay, so now, what are we interested in? This region here, shading in between. All right, so let's review a second what we've done here to set this up. We've identified what we need to do, find the probability. We've checked our conditions. We know our mean and our standard deviation of the sampling distribution. We've calculated a couple of z-scores. We've shaded appropriately. We're now going to look this up on table A or normal CDF on your calculator or whatever software website you want to go to plug this in. There's so many different ways to do this. I'll leave that to you, but your answer should be 0.8961. And so the third step for all these z problems is to answer the question. So let's do that. 89.61% chance that my p hat for these 1,500 will be between 0.33 and 0.37. Okay, and that makes sense to you, right? I mean, there's 90% chance almost, of course, because if the actual p is 35% and I do a good sample, I should be pretty close to that. And that's how this works. So this is how you do a sampling distribution problem with proportions. Key formulas right here. All right, our key formulas. Okay, the next one we'll do will be a sampling distribution with means, and we'll see how it differs slightly, but very similar process. Okay, good luck. See you next time.